All right.
You're kind of crafty, but
It's okay.
So we had the test yesterday.
I want to run.
These are the grades. Yeah, so you might have noticed the test corrections are automatically set up in Delta Math now. That was a good improvement that they just
yeah,
made.
that's cool.
Yeah, it makes perfect sense. They just link it right to the test, and then that's it. Kind of cool, and it saves you a lot of time. If you're going to do that assignment, make sure you do it before Monday. Any questions on that? Okay, so we're going to continue talking about limits, but now we're going to talk about how do you calculate limits analytically if you don't know what the graph looks like. This is finding limits. Analytically. Okay. So here's a really important fact. If f of x is a polynomial,
These notes take up like an entire page.
I don't know, I haven't done them yet. This is my first time. Sorry. They might. If f of x is a polynomial or a rational function, I'm just totally making these up. It's true. Or a rational function and if f of a is a real number, then the limit x goes to a of f of x equals f of a. So what this is basically saying is, i.e., what does that stand for? I.e. No, that's what it means, but it must stand for something. I don't know what it stands for. Something Latin.
I'll look
maybe.
at it.
It has
Thank you.
Informative explanation.
Is that what it is?
I have no idea.
That's not real.
I'll look it up. No, I'm doing it right now. No,
It's a race.
it's fine. My Wi-Fi is not very good.
Okay. What this is really saying is, if you can, what does it mean?
It's Latin. It means it is, which means that is.
Ah,
That's interesting.
good to know.
I know that now.
Good to know stuff like that. So is s, if you can plug the number in and you get an answer, then that's all you have to do. If the x value can be substituted in, get a number, and that number is the limit. Okay, so like for example, if they gave you something like find the limit as x goes to 3 of x squared minus 2x plus 5. All you have to do is take that 3 and substitute it in for x. That's it. So this would be 3 squared minus 2 times 3 plus 5. So this is 9 minus 5, or minus 6 rather, is 5 plus 5 is 10. The answer is 10. And the actual like theory behind this is polynomials are completely continuous. And you know that if you have a completely continuous piece of the function, then the limit and the y value are really the same thing. So that's really all you're doing is you're just finding the y value because the limit and the y value are the same thing in this case. Okay? Same thing goes for if you have a rational function. Like if I had something like the limit as x goes to -1 of x squared plus 2x plus 3 over x plus 5. I could just take -1 and substitute it in for x. So I get -1 squared plus 2 times -1 plus 3 over -1 plus 5. So this ends up being 1 minus 2 is -1 plus 3 is 2 over 4. The answer is 1/2. And it's the same concept. If you have a rational function, the only places where a rational function is not continuous is places where the denominator is 0. So as long as you can take this number and plug it in and you don't get a 0 denominator, that's a continuous part of the function. So the limit is just the y value at that point. And it could be like scarier looking. Like if I had something like the limit as x goes to -5 of something like x plus 4 to the 101st power. I mean, that's not hard to calculate. This would just be -1, substitute it in, you get -1 to the 101st power. What's that? Simplified. It's just -1, that's not that hard, right? So remember, every even power of -1 is going to be +1, and every odd power is going to be -1. So it's an odd power.
Is it -5?
Yeah, I substituted -5 in for x.
Oh, he did say -1 out.
No, I said it's -1 to the 101 because when you substitute -5 in, you get -1. Yeah, sorry.
Thank you.
Okay, and this could also work if you had something that involved like weird stuff like trig or exponentials or something like that. Like if I had something like the limit, find the limit as x goes to 3 of cosine x pi over 4, something like that. I could just take 3 and substitute it in and get an answer. It would be the cosine of 3 pi over 4. So 3 pi over 4 is 135 degrees. So this would end up being negative radical 2 over 2. Okay? Any questions on that stuff? So that's the first thing. If you have a polynomial or a rational function, and you can take that number and substitute it in and you get an answer, that's all you have to do. So the next thing I want to talk about is what if it's a piecewise function? So for a piecewise function, there are really like two possibilities. And the possibilities are either the pieces match up or they don't match up. Those are the options, right? So either pieces match up which in terms of a picture, it might look like this. Like it might be like a parabola that then goes into a line or something like that. But they match up. Like at that point where the pieces change, they actually change at the same y value. Or it might even be a situation where the function is going along and then it's undefined, but then it continues the same path. So it could be missing a point, but they're gonna match up. Like they're going towards the same spot. remember with limits, we don't care about just random holes like this. That doesn't affect the limit values whatsoever, right? Or the second possibility is that the pieces don't match up. So this would be the situation where the function's going along, maybe it's a parabola again, but then it suddenly is a line that's somewhere else, and they don't match up. There's a big gap there. There's a jump in the function. And maybe this dot is filled in, or maybe this dot is filled in, or maybe neither of them is filled in, and there's a random point, whatever. It doesn't matter. The point is there's a jump in the function. So the question is there a way to determine which of these possibilities is actually occurring by looking at the function analytically and not knowing what its graph looks like? For example, suppose I have something like f of x equals, let's suppose the function is x minus 2 if x is less than or equal to 3, and suppose it's x squared minus 8 if x is greater than 3. So here's how to tell which of these possibilities is actually occurring. All you need to do is think of 3 as being like a part of the first function and also a part of the second function, and see if you get the same y value. That's all you do. So you're going to take 3 and plug it into the top, and you're going to take 3 and you're plug it into the bottom. Even though 3 is not included in this interval, you just pretend like it is. Okay? So to determine the one-sided limits, you just plug in the x value to the appropriate function. And when I say appropriate, what I'm talking about is, like if I'm going from the left, for example, the appropriate function is the top function, because that's the function that f of x actually is to the left of 3, right? If x is less than 3, that's to the left of 3, the function is this. So that's the appropriate function if I'm trying to find the left-sided limit. If I'm trying to find the right-sided limit, then I plug 3 in here, because this is what the function looks like if x is to the right of 3. Okay, so if I'm trying to find the limit as x goes to 3 from the left, this is really just going to be the limit as x goes to 3 from the left of x minus 2, which I can get by just substituting 3 in. I get 1, right? 3 minus 2. And if I take the limit as x goes to 3 from the right, f of x, that's really equal to the limit as x goes to 3 from the right of the bottom function, x squared minus 8, which is also 1. If I substitute 3 in here, I get 9 minus 8, which is also 1. So since these things are equal, then the limit as x goes to 3 of f of x equals 1. If these things were different, just like graphically, if these one-sided limits are different, then this limit would just be, does not exist. So by plugging the number in to the left and the right, to the top and the bottom function, I've determined that it's actually one of these situations where the pieces are going to match up. Okay, if I had gotten different y values, then you know the pieces aren't going to match up. So what this function actually looks like, it's a line. It looks like this. So here's 3 and 1. There's the point 3, 1, right? To the left of that, it looks like a line of slope 1. So it goes like that. To the right of that, it looks like a parabola opening upward. So it kind of goes like that. Something like that. Okay, that's what this function looks like. Definitely the limit exists. It's a continuous part of the function. Okay? The summary is, if you're trying to find the limit as x goes to the point where the function changes, like which is 3 in this case, just plug 3 in there and plug 3 in there. If you get the same answer, then that's the limit. If you get different answers, then the limit doesn't exist. Okay? Let's try again. Suppose I have something like g of x equals, let's say it's the function negative 4 plus x squared if x is less than 3, and 10 minus 3x if x is greater than or equal to 3. So all you're going to do is you're going to take 3, substitute it in for x there, which would give you negative 4 plus 9, which is 5, and then take 3 and substitute it in for x there, which would give me 10 minus 9, which is 1. These are not equal. So if they asked us what's the limit as x goes to 3 of g of x, you'd say it does not exist. If they asked you either of the one-sided limits, they're right here. This is the limit as x goes to 3 from the left side, and this is the limit as x goes to 3 from the right side. So we can answer any of those 3 questions. Go ahead.
Normally oriented with like left first, right bottom, or is that irrelevant?
I don't know. No, they don't have to be. There's no rule that says that this has to go like from left to right. There's no rule like that. Is that what you're asking?
It wasn't really, I don't know. It was just kind of like, sort of.
Yeah, it doesn't, these functions can be switched, and that's perfectly fine, and they might be. I don't really know how they arrange it usually on Delta Math. Okay? Let's try another one. Suppose we have f of x equals pieces. Let's say it was something like negative 4 minus x if x is greater than 2, and x squared minus 10 if x is less than 2. So this one I arranged them differently, right? And notice I also didn't include 2 in either of these endpoints, right? 2 is not included here, and 2 is not included there. But that doesn't have anything to do with whether or not the limit exists, right? It could be a hole in the function, right? Like I could have even included a third interval or third piece of the function, and I could have said, suppose it's 7 if x equals 2. This doesn't matter at all. Like I can totally ignore that part of it. When I'm calculating limits, I don't care what's happening at 2. I only care what's happening near 2. Okay? So now what I'm going to do is I'm going to take 2, substitute it in here, so I get negative 6, negative 4 minus 2. And I'm going to take 2 and substitute it in here, so I get 4 minus 10, which is also negative 6. So even though this does not agree, it doesn't really matter. These do. Those are equal. So the limit as x goes to 2 of f of x equals negative 6. That's the answer we're looking for. Does that make sense? Okay. So there's the assignment that's on Delta Math. I don't think there's any like just polynomials and rational functions, but you should keep that in mind because we are going to do an assignment eventually that has those in it. But there's piecewise functions. So all you're going to do for these piecewise functions is take the number that where the function changes, substitute it in for x in one piece, and substitute it in for x in the other piece, and see if they agree. Any questions? Great question. No, there's no quiz tomorrow. It's just gonna be like a free day. So if you're not gonna be here, you don't have to like log in or anything like that. Good question. Normally we would have a quiz on the Wednesday, but we just have a test, so there's nothing. Which,
Okay.
all right, that's it. So the homework's just called finding limits analytically.
Could you scroll back to the first piecewise function?
Yeah, sure, Tommy. Is it this one here?
Yep.
Okay. Yeah, sure. Yeah, of course.
Me too.
Yep.
But it's also, my back would have some. Like if it was in the